Earlier in the course, we talked about polymorphism. I told you that polymorphism is a mechanism that allows an object to take on many different forms. So earlier we built this UI control class. We declared this as abstract because it has a single abstract method. Abstract methods are methods that have no implementation. So here we have a draw method, but we don't know how to draw a UI control. The drawing algorithm will be dependent on the type of the UI control. So we created two specific UI controls. One of them was the textbox class, which extends the UI control. And this is where we're implementing the logic for drawing a text box. Now, in our main class, we had code like this. We declared a static method called drawUIControl, which takes a UI control and simply calls control.draw. Now, depending on the type of the object that we pass to this method, our application behaves differently. This is polymorphism in action. So if we pass an instance of the textbox class, the draw method of the textbox class will be called, even though we're working with the UI control class here. So this control object can take on many different forms. This is polymorphism. Here's the UML diagram of these classes. So our main class talks to the UI control, which is the parent or the base of these two classes, textbox and checkbox. In UI control, we have an abstract method called draw, and we have implemented this method in our child classes. Now we can use the same technique to get rid of those ugly if and else statements in our canvas class. So here's our canvas class. We have the current tool field and these two methods. We want these methods to behave differently depending on the current tool. So we introduce a new class called tool. This is going to be an abstract class like our UI control. In this class, we're going to declare two abstract methods, mouse up and mouse down. What happens when the user releases the mouse button will be determined in child classes. So we introduce new classes like selection and brush. And in these classes, we're going to implement the logic for mouse up and mouse down events. Now, our canvas class is going to work with the abstract tool class. It doesn't care about any specific tools, but it will behave differently depending on the specific tool that we give it at runtime. And this is what we call the state pattern, because the state pattern allows an object to behave differently when its state changes. Now, if you look at the classic definition of the state pattern in the Django 4 book or other books and courses, you're going to see different labels. So instead of canvas, we have context, and instead of tool, we have state with two concrete implementations. Also, instead of mouse up and mouse down methods, we have the request method that is handled by the state class. So as I told you before, this is just an abstract concept. It doesn't mean you should name your classes context or state. They're too abstract. Always use meaningful names that fit the domain of your application. Next, I'm going to show you how to implement the state pattern in code.